So for number 1, what kind of special right triangle situation is this? Caden.
I was going to ask if you see
There's a line after the warm-up. You can go after Jalila, okay? Caden, do you know what kind of special triangle scenario this is?
40. Oh, wait.
Caden? It is a right triangle, but there's 2 special cases. What is this one? 45, 45, 90. Let's go. Okay, so write down 45, 45, and 90. Now, there's another part that you have to have memorized for your quiz. What goes underneath the 45? A. What goes underneath the 45? A, because they're the same length, right?
Yeah.
And then what goes underneath the 90?
2 times the power. Wait, no.
A times the square root of 2. Cool beans? All right, now in our scenario, then you look, what is A the same as? X. So put an X under there and an X under the other A. And what's A times the square root of 2? 4 times the square root of 2. Because remember, the side opposite your 90 degrees is going to be A times the square root of 2. In other words, your hypotenuse. Are we cool with this?
Yeah.
So we set these equal. So we know A is equal to X twice, right? So we don't need to write it 2 times. And we also know A times the square root of 2 is equal to 4 times the square root of 2. So guys, what would we do to solve for A? Sophia? It's just 4, okay? So A is equal to 4. So then X is equal to 4. Yeah.
One of those, so you know how you did the 90 as a cross?
Yep.
In that occasion, it's just like, it wouldn't always be, like, so there it was the same thing as like 4 over 2 over 2. Sometimes if it was just like 3, you would just do 3.
And then divide it by the square root of 2. Yep. Good question. All right, any questions on number 1? Sophia?
I accidentally did this backwards and still somehow got 4. So first I did x squared, x squared times x squared equals 4 square root of 2 squared.
Oh, use the Pythagorean theorem?
Then I ended up with 2x squared equals 16 times 2.
Mm-hmm.
Then got 2x squared equals 32.
Yep.
And I just divided 32 by 2. X squared is equal to 16, and then x is equal to 4.
Yeah, so for these 45, 45, 90 scenarios, you can absolutely use the Pythagorean theorem. This is going to be your A, right? This will be your B, and this will be your C, right? You square all of them, set them equal to each other, okay? A squared plus B squared equals C squared. You're going to be able to do it. I personally, in my opinion, think that this method is a little bit harder, okay? I would stick to the special right triangle scenario. Yes?
Like in the book, it says that, like, I got the same answer, but it says that, like, your the hypotenuse for 2 is equal to a leg times 2 square root.
The square root of 2, yep.
Yeah, and then, like, when you get that, like, I still got 4.
Correct. Yep. So we just need to figure out, okay, well, if this hypotenuse is the leg times the square root of 2, then our leg needs to be the 4, right? Okay. I always set it up like this so we can never go wrong, okay? Because that'll work regardless of what they give you as the hypotenuse. Dylan?
What are the next office hours?
The next office hours? Tomorrow morning. Okay? Yeah, Zoe?
Could, for 30, 69 triangle, could you also use a squared plus b squared equals 6 squared?
No. So that one you can't because 2 of the legs are going to be different. In this case, the legs are going to be the same, so they're both x. So you'll end up getting 2x squared in your Pythagorean theorem. That's a really good question, though. Okay? All right, number 2. Again, 45, 45, 90, correct? So 3 is a leg or the hypotenuse? A leg, and it has to be the same as this leg. Do you guys agree? So what's the length of this one over here? 3. Okay? That means that x is going to be equal to 3 times the square root of 2. Okay, so remember, we set it up. This is 45, 45, and 90. Okay, our two 45s are A, and then 90 will be A times the square root of 2. We know that our A's are 3, agreed? Yeah. And then X is going to be A times the square root of 2. So if a equals 3 and x equals a times the square root of 2, you make that substitution for a, and you've got x equals 3 times the square root of 2. When you plug that into your calculator, we should get like 4 point something? 4.24, which rounded would be 4.2. Three times the square root of 2, 4.2. Are we Gucci on 2? Gucci Marucci? Any questions? Okay, now on your quiz, okay, I just went over it again. It's very specific. It'll tell you to keep like rounding to the nearest tenth, okay? You don't have to worry about simplifying any radicals on your quiz. Does that make sense, guys? Okay, you're just gonna round everything to the nearest tenth.
So if it's 3, like square root of 2, you would have to like put that into the calculator and get.
Correct. So there is a theorem that says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. This is a theorem, okay? We're going to see this theorem in action in the next slide, but all you need to know is that this altitude, which is drawn from the right angle down to the hypotenuse, creates 3 triangles that are similar. The original one, which is CAB, the one on the right, which is ADB, and the one on the left, which is ADC, okay? They're all similar to each other. All right. Now, what I want us to do for this next slide is I want us to draw out all 3 of the triangles, okay? So, go ahead and draw the really big one, which includes the whole thing. So it looks like this, kind of, not really. I did a really bad drawing, but this would be W, this would be X, and this would be Y. You guys following? So that's the really big one around the entire thing. Do you guys see that? I'm not talking to myself, am I? Okay. Now, let's draw also the really small one in here. Do you guys see that one? Okay. So go ahead and draw it with a different color. It looks kind of like this. And there's a 90-degree here. What are the letters? W, Z, and Y. Okay? And then I also want you to draw the green one, which is like the medium-sized one. Do you guys see this one over here? So draw that one as well, which looks like this, which is Z, X, and Y, okay? It's also 90 degrees here. Okay, now each of these triangles, okay, is gonna have a long leg, a short leg, and a hypotenuse, okay? So let's label them. In the red one, what would be the short leg of the red triangle? Emma?
YX.
Good. Put an SL here for short leg, okay? All 3 of these triangles are going to be similar. So we're going to say, all right, the XY is going to be our short leg. Let's do the same thing for the blue one. So in the blue triangle, what side would also be the short leg, which would be proportional to YX? Emma? Excellent. So SL next to WZ. And the last one, I didn't draw it great, but look back at the figure. What would be the short leg of the green triangle, guys? Gabby? YZ. Okay? So all 3 of those sides, since these 3 triangles are similar, are proportional. Okay? Let's do the long leg, LL. What's the long leg of the red triangle? Emma?
WX.
No. That's the hypotenuse.
I mean WY.
Good, WY. So long leg, double L. What's the long leg of the blue triangle? Gabby?
YZ.
YZ. And what's the long leg of the green one?
ZX.
ZX. And then let's finally label our hypotenuse. What's the hypotenuse of the red one? Emma?
WX.
Good. Just label it H. Hypotenuse of the blue triangle? Emma?
WY.
Good. And the last one? Go ahead. YX. Okay? So what we're going to be able to do is set up proportions to solve these. We're also going to be able to write a similarity statement about all three of them. Okay? So in our similarity statement, okay, let's write out each of these three triangles saying that they're all similar to each other, but we have to be careful about what in our similarity statements. What matters in the similarity statements?
The order.
The order of what?
The letters.
The letters, okay? So what I want us to do is circle each of the letters that has the right angle. That's where we're going to start each of our similarity statements, okay? So we're going to say, all right, triangle Y, because that's the red triangle, and that's going to be similar to triangle, let's start with Z for the blue one, and then we're going to start with triangle Z for the last one, for the green one, okay? Now, you can go whichever way you want, but if we're starting with Y in the red one, where would you guys like to go? To X or to W? It doesn't matter. Just pick one. Let's go to X, okay? Do you agree that if we go to X, we're going along the shorter leg? Okay? So, that means let's write from Y to X in the red one. So put an X in your similarity statement. And then check out the blue one. We would have to go from Z to where? To W. Why to W, guys? It's SL as well. Do you guys see that? So in your blue one, you're going to go from Z to W. And in our green one, we're going to go from where to where? From Z to, Emma? Y. Okay? So we go from Z to Y. And then the last one's really easy. You just fill in the last letter. So what's the last letter in the red one? W. What's the last letter in the blue one? Y. And what's the last letter in the green one? X. So this is our similarity statement. Jaden. Wait, no. Jalila, you went?
Yeah.
Kaden, did you? Oh, Kaden's out. When Kaden comes back, then Giselle gets to go, and then you get to go. Draw it out, draw it out, draw it out. If you don't draw it out, you're going to get confused. I promise you, okay? So, first let's draw the largest one. What's the largest triangle? What are the letters of it? R, S, and T, right? So start here. Let's do the same colors. So we're going to start with that red one being the largest. R, S, and T. You guys see it?
And then is UTR the small one?
What's that?
Is UTR the small one?
UTR is the medium one, and the smallest one will be SUT. Okay? So let's draw that one. The medium one is going to be RUT. This looks like this. Except my right angle is up here. Do you guys see the difference now? This is my U, this is my T, and this is my R. And then the last one is the smallest one, which looks like this, where this is my right angle. This is U, S, and T. Are you guys following with drawing out the triangles? Kind of a little bit or no? This is the biggest one. This is the medium one. And this is the smallest one. All right, where do we always start in our similarity statement? The 90, okay? So circle all your 90 letters, which are T, U, and U. And then let's label. What's the smallest leg in the red triangle? ST, right? So put SL where ST is. put LL where RT is, and put H where RS is. Cool? Then in the blue one, UT is going to be our small leg. UR is going to be our long leg. And H is going to be RT. Our hypotenuse should always be opposite the 90. And then in the green one, your short leg is going to be US. Your long leg is going to be UT. And your hypotenuse is going to be ST. We're going to start at the 90 and we'll go along, let's go along the short leg again, okay? For all of them. Start at the 90, go along the short leg, start at the 90, go along the short leg. So our statements are going to start with T, go to S, and then give us R, is similar to triangle. U, go to T, and then go to R. And then the last one is going to be similar to triangle. Start at U, go to S, and then go to T.
Is that all this lesson is, just the statements?
There's more to it. We have to create proportions as well. Have to remember that. So whenever you have an altitude drawn inside of a right triangle, it creates 3 similar triangles that we just drew out. Do you guys see that? Okay. See how some of the sides are being used twice, right? Like take a look at this altitude. Do you see how UT is being used in the blue triangle and it's also being repeated in the the green one? Do you see how this side UT right here, it's being used here and it's also being used here? When we're setting up proportions, that means if we don't know what UT is, it's going to be used twice in our proportion, okay? Okay? Something's going to happen and that something is called a geometric mean, okay? So since all these triangles are similar, okay? So that leads us to a definition called a geometric mean, okay? So when your unknown value, highlight the 2 x's, are across from each other in a geometric mean, we're going to get x squared. Do you agree? Cross multiplying here would give us x times x and a times b. So that would give us x squared equals a times b. And then you take the square root of both sides and you get x equals the square root of a times b. This is what we call, when this scenario happens, it's called a geometric mean. So if you're ever asked to find the geometric mean of 2 numbers, you multiply them together and then take the square root, okay? All right, let's just see 2 examples really quickly. So we're asked to find the geometric mean of the given numbers. So for 4 and 20, okay, to find the geometric mean, you just say that the mean equals 4 times 20, and then we take the square root. So plug into your calculators. 4 times 20 should give you 80, right? And then you take the square root of that. So you're going to get the square root of 80, which is 8.9. All right, if it asked us to find the geometric mean of 9 and 25, we would say the geometric mean is the square root of 9 times 25. 9 times 25 is going to give us 225, and the square root of 225 is 15. Make sure you guys are plugging these into your calculator so you get the practice, okay? Did we all get these? Xavier, what's up?
Where did you get 225?
9 times 25. Okay? Not yet. Dicey, guys, okay? Please follow along as best you can. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse, okay? So, in other words, if we're looking at the altitude, okay, it's going to be used as the longer leg for the triangle on the left, and it's also going to be used as the smaller leg for the triangle on the right. So let's see where this comes from, okay? Underneath this, I need you to draw both triangles, both small triangles, okay? So draw the one on the left, which looks like this. Not really, it's a little bit smaller. With a 90 degree, and draw the one on the right. Okay? Do you guys agree that this bottom side of the blue triangle is the shorter leg? And do you agree that this right side of the blue triangle is the larger leg?
Yeah.
So put LL. And now, if you look at the red triangle, this altitude, or where our altitude was, right, is now the shorter leg. And this bottom side is now the longer leg. So let's set up a proportion, okay? Our shorter leg here is proportional to the shorter leg of this triangle. Agreed? So we're going to say in blue, our shorter leg over the shorter leg of the red triangle creates a proportion that should be equal to the longer leg of the blue triangle over the longer leg of the small triangle, of the red triangle. So notice, your blue lengths are in your numerator, and your red lengths are in your denominator. Okay, now, what it's saying is, your altitude, in other words, this length right here, is going to be used twice. If that length was x, it would become x squared. And we're going to finish this up tomorrow.